Okay, so we now move on to unordered selection without repetition for sampling. As per usual, I'll start with the definition of the sample space for such a scenario. So if we make an unordered selection of R elements from a set X without repeat elements, then the sample space is a set of all R elements subsets of X. Then it's got the sample space is equal to A, which is the element of the power set of X, such that modulus of A is equal to R, or that the sample space is equal to the set A, such that A is a subset of X, with the modulus of A equal to R. Okay, so we know that we're dealing with sets now, right? So we can denote the cardinality of a set by the modulus of it. So the modulus of A is obviously R. And since we're always going to have R element subsets, that is the reason why it's wrote modulus of A equal to R. Obviously with sequences, there isn't such a definition for cardinality, it doesn't exist. So that's the reason why that wasn't in the definition for sequences. And then obviously we're dealing with sets, right? And so every event is going to be a set. Hence the reason it's got A as an element of the power set of X, or A is going to be a subset of X, because don't forget X was the set of which all the elements come from, and so every event is going to consist of all these elements of X, but it's going to be a subset instead of a sequence. Okay, and then we've got obviously that you know the modulus of the sample space is equal to n choose R, but just a quick note on how we get n, how we actually get there. You see in his notes he's got you times it by R factorial. That's simply because if we look at a basic example just to briefly illustrate it, this was a scenario where I had 3 cards were drawn from a deck, and the probability of getting I wanted the probability of getting a 7, then a 2, then an ace. Well, let's say I didn't care about the order. I just wanted a 7, a 2, and an ace. I didn't care about the 7 being first, and so on and so forth. Well, this is going to be, now I'm going to have a 3 element set, and how many ways are there to rearrange 3 objects? Well, it's 3 factorial. So for the general case of R objects, there's going to be R factorial ways of rearranging it, and every single event in the sample space is going to have R factorial ways of arranging itself. Hence, you end up times in the whole sample space, modulus of the sample space, I should say, by R factorial, and then obviously you divide it, and then that's how you derive n choose R. Just briefly, anyway, just as a quick mention. Okay, so we'll look at an example now. So let's say you wanted to find out, so you've been given this scenario. So a box contains 15 light bulbs, of which 5 are rated 13 watt, 6 are rated 18 watt, and 4 are rated 23 watt. 3 of these bulbs are randomly selected. So we'll start with the first question. What is the probability that exactly 2 of the selected bulbs are rated 23 watt? Okay, so I just wrote briefly the key information on another page so that I just don't have to keep interchanging. Okay, so we've got 15 in total. 5 are 13 watt, 6 are 18 watt, 4 are 23 watt, and 3 are selected. Obviously, if you want to let me just put this through it. If you can just do the questions. If you just want to do the questions, then obviously you can just pause it here and attempt all the questions, and obviously I'll go through them. Right, question 1. Okay, so we want the probability that exactly 2 of the selected bulbs were rated 23 watt. Okay, well let's look at, so what do we want first? We want the modulus of the sample space. That's the thing you're going to immediately want in the exam, right? Well, there's 15 in total, and I'm picking 3, so it's 15, and I'm choosing 3. 15 choose 3, pretty simple. I'm not going to simplify it, but I'm just going to keep it like this. But yeah, 15 choose 3. Okay, so we want the probability that exactly 2 of the selected bulbs are rated 23 watt. So we'll call that event A. Okay, so we'll call that event A, and we want the modulus of A. So let's think about it, right? If you have, a set, right, 23 watt. Let's call this 23 watt 1, 23 watt 2 for the first 23 watt light bulb, the second 23 watt light bulb, and then you're going to have a third light bulb, but it can't be a 23 watt light bulb, so it's got to be a 13 watt light bulb or an 18 watt light bulb, right? So in the event that is a 13 watt light bulb, what's that going to be? Well, we want 2 23 watt light bulbs, and there's 4 available, so we're going to do 4 choose 2. But obviously we're picking 3, right? So we've still got 1 left over. So in the 13 watt scenario, we only want 1 of the 5 13 watt bulbs. So we're going to do 5 choose 1, right? But what else is there? Well, I could also have two 23 watt bulbs. So again, I could have 4 choose 2. Note that I'm adding, because this is a new scenario of 4 choose 2. Well, I could also have the 18 watt bulb instead. So as my third choice. So out of the 6 18 watt bulbs, I only want 1. So obviously I need to have, it needs to go add up to 3, right? Because obviously, also note that you see 2 and 1 make 3, 2 and 1 make 3. You always want your bottom numbers to add up to how many are selected. In this case, it's 3. Hence the reason why I've got 2 and 1 for both. So this is the scenario that I select two 23 watt bulbs, and then there's a 13 watt bulb, which is the third bulb that I selected. And this is the scenario that I select two 23 watt bulbs, like the question asks, but the third bulb, since I have to pick 3 bulbs, is an 18 watt bulb. Obviously, I'm not going to have the scenario of 3 23 watt bulbs because we only want exactly 2. So what's the probability of A? Well, the probability of A is going to be 4 choose 2 multiplied by 5 choose 1 over 15 choose 3 plus the probability of 4 choose 2 times 6 choose 1 over 15 choose 3. So it's just a bit difficult to write. Let me just move this down a bit. Okay, hopefully you understand that. And you should, when you do that, you should get an answer to 3 decimal places of 0.145. Okay, so now we've got the second question, which is asking what is the probability that that all 3 of the bulbs have the same rating. Okay, let's look at that scenario. So again, we'll call this event B just for convenience. Our modulus of the sample space is still going to be 15 choose 3 because nothing's changed there in terms of how many we're picking. So what's the modulus of B going to be? Well, the modulus of B, so all 3 are the same rating. So I'll pick 3 and they're all the same. So, well, there's a 23 watt scenario in which they're all 23 watts. So out of the 4, if they're all the same, I'm choosing 3. I've also got the scenario of they're all 18 watts. So out of the 6 18 watts, I end up choosing 3 of them, selecting 3 of them. And then I've got the 13 watt scenario, of which out of the 5 of them, I am selecting 3 of them. And so the probability of B, which obviously is the modulus of B over the modulus of the sample space. I should have stated this for the A one, but it's kind of just, me being, extra, is going to be 4 choose 3 plus 6 choose 3 plus 5 choose 3. Obviously you can just have it over the same denominator because they're all the same common denominator. 15 choose 3. Hopefully that's clear, and thus you get, is that 3 clear? Hopefully that is a 3, by the way. You should get 0.264, I think. So yeah, hopefully that scenario is clear. Now let's go on to the third question. So what's the probability that one bulb of each type is selected? Okay, so we pick 3 and 1 bulb of each type is selected. So we'll call this event C. What's the modulus of C, right? In case it isn't clear anyway, the reason why I haven't, wrote out the sets for B and the sample space, or the set of the sample space, because in the exam you really won't care about it. You won't need it. You're going to go straight to the probability. And yeah, that's what he wants to see as well. So the modulus of C, well, what's that going to be? So 1 bulb of each type is selected. So there's 1 23 watt. Okay, so out of the 4 23 watts, I'm picking 1. 1 18 watt. So out of the 6 18 watts, I select 1. And 1 13 watt, sorry. So out of the 5 13 watts, I've got one of each rating, right? So obviously the probability of C is going to be 4 choose 1 over 6 choose 1 over 5 choose 1 over the sample space 15 choose 3. And you should get to 3 decimal places 0.075. Okay, now here the fourth question. If bulbs are selected one by one until a 23 watt bulb is obtained, what is the probability that it is necessary to examine at least 6 bulbs? I'll leave this for you to answer if you want to, but I will leave the answer. The answer of it is 0.154. Obviously you see that this is a different scenario. This question is from a book, and so this was like the 4th question. So I thought I'd just throw this in anyhow, just in case people want to work it out. Obviously, I'll provide a solution if it becomes difficult, but it's not too bad. But although I didn't use the same method that I used to solve the other 3 questions, as you'll probably immediately tell because it's a different scenario. So hopefully that's an example of just unordered selection without repetition. Again, it just comes with practice, really. Once you've practiced it, that's really it. You just memorize the formulas required and work out the probabilities accordingly. That's really it. So next I'm going to go on to conditional probability, and focus on mutual independence, pairwise independence, and all these funny names, and see what they mean and stuff like that. And yeah, I think that will be it. Obviously, if you see any errors in the video, please do let me know. I will have future examples of sampling. I just want to get through the module first. That's what I decided to do, get through the module first and then have a bunch of examples. It seems that now the focus has shifted to chapter 7, the whole total probability in terms of what people find most difficult, and not sampling anymore. So that will be the new emphasis, I guess. So yeah, I think that will conclude the video. Hopefully everything was clear. If not, then obviously let me know, either at university or just in the comment section. That's perfectly fine.